In this video, we will be talking about the handshake formula. Actually, this formula doesn't have a definitive name, but I'm choosing to call it this because it's more memorable. The goal of this video is not just to show you this formula, but also to take you on a journey where we will discover it for ourselves. So let's begin with questions to motivate our search. What's 1 plus 2? How about 1 plus 2 plus 3? What if I ask you to keep on going to 1,000? You see that with more numbers to add, the time it takes you to do this becomes longer and longer. If you already know how to do this, then you know there's actually a formula that solves a specific kind of problem, in which case the answer is 500,000 and 500. So the goal here is to solve this problem in a way so that we can go as big as we want and still know what numbers add up to. The problem at hand in a more formal light can be worded like this. Given the numbers 1 through n, we're interested in finding a closed form formula that yields us the sum for any n that we choose. What is a closed form formula? A closed form formula usually means you can just plug in numbers and find your result, no extra work needed. In the context of our problem, adding isn't difficult. Adding for thousands or millions of times, however, is inefficient and takes time. Our goal is to come up with something that gives us an answer in one shot, no matter the size. To begin our search for a closed form formula, let's begin by looking at some simple examples. We have 1 plus 2, plus 3, and plus 4. We are also going to rewrite this in sigma notation, but it means exactly the same thing. If we just look at the numbers and the symbols, it's not very helpful for developing intuition on how we can do this. But maybe there could be a different way for us to see these examples. Instead of seeing these as numbers, let's try expressing this spatially and draw the 1 through 4 example with dots. If we count the dots, it's very clear that there are 10 of them. Now, what if we rearrange the dots in a different way? Say, a triangle. Now, we should all know how to find the area of this triangle here. So really, the number of dots we have is related to the area of this triangle. But let's be careful here. If we just look at the sides of the triangle and find its area, you'll see that 4 times 4 over 2 gives you 8, which is incorrect. However, let's add the same set of dots in such a way that it forms us a rectangle. Now it's easier to see that the number of dots we're counting is exactly half of this rectangle, where one side is 1 longer than the other. So 4 by 5 over 2 is 10. That is the correct answer. What if we were just lucky? Well, let's try a bigger number now. This time, we're setting the number to be 10. You can feel free to pause the video and count the dots to convince yourself. Hopefully, you see a pattern here now. The summation that we want to do is directly related to the number of dots in the triangle that we made. If we take this to a value of n, where we don't know what n is, we can see the formula that we have is n by n plus 1 over 2. This is what I am calling the handshake formula. Now that we have discovered the formula, let's revisit the question from the beginning of our video. If I take 1 and add 2, add 3, and keep on adding to 1,000, we can see that our value of n here is 1,000. So let's plug it in. 1,000 by 1,001 over 2 is precisely 500,500. If you have the patience, you can try to do the addition manually and check. Anyways, we found the answer much more faster this way. This is the beauty in having a closed form formula. There's only one addition, one multiplication, and one division, regardless of which value of n that you choose. But wait a minute, you might ask. Why is this the handshake formula? What does this have anything to do with handshakes? As it turns out, if you have n people in a room, and you want everyone to shake hands with each other, then the total amount of handshakes will be related to this formula. Now let's have a closer look at this situation. Say I have four people in a room. Person 1 needs to initiate three handshakes. Person 2 already shook hands with person 1, so they only need to initiate two handshakes. This leaves person 3 with initiating a handshake with person 4. 3 plus 2 plus 1 is 6. There are 6 handshakes to take place here. Hopefully, we can already see a pattern here, but let's make it more explicit. Let's make a table of who will need to shake whose hand. It takes two to make a handshake, so we're going to have a table where each row is a person and each column is a person as well. There are 16 cells. Each cell means there could be a handshake. If we shading every single cell in this table, then we overcounted by a large amount because there will be 16. As a matter of fact, there are some redundancies in our table that we can eliminate. To begin, it takes two for a handshake, so it doesn't make sense we have a person shaking their own hand. Now, handshaking is a mutual act. Person 2 shaking hands with person 3 is the same as person 3 shaking person 2's hand. This means that only half of our table needs to be filled. Now, when we fill all the remaining cells, there will be 6 handshakes that take place. Doesn't this look familiar? By drawing out our table, we have discovered, yet again, the basis to our closed form formula that we just talked about. But now it's in a bit of a different form. You see that our original formula is n by n plus 1, but this one is n by n minus 1. So what's happening here? Actually, it is still n by n plus 1. The thing that has changed is that the value we put in for n is now n minus 1. With n people, the person that initiates the most handshakes will shake n minus 1 hands, and not n hands. After some algebraic simplification, we can see that now the n by n plus 1 formula becomes n by n minus 1. It's easy to get these two confused. So oftentimes, I don't recommend that you just memorize these two formulas, but rather understand the process that this formula comes about. And depending on the situation where you will need it, you can just go ahead and work through this process again in your head really quickly, and then always come up with the correct formula. That is all I have for you today. I hope you have learned something new, and I will see you next time.